In this video, we will focus on how electrons are arranged in an atom. By the end of this video, you will understand how electrons are arranged in atoms, and you'll be able to write down the electronic configuration of each atom. Let's get started. The electrons in an atom move around the nucleus in electron shells. The way the electrons are arranged in an atom is called its electronic configuration. The shell which is further from the nucleus is called the outermost shell or valence shell. The electrons in this shell are called outermost electrons or valence electrons. These are the electrons involved in chemical bonding. Now, we know that electrons are negatively charged, and the nucleus, due to the presence of protons, is positively charged. So, electrons are attracted to the nucleus. The closer an electron is to the nucleus, the stronger the attraction. Now, imagine the nucleus is a very strict mother. The electrons are her children. Now, the children who stay closest to their mother are under strong control. They behave well and have lower energy. The children who are further away from their mother feel less of her strict control. They become wilder and have higher energy. So just like kids become wilder the further they are from their strict mother, electrons have higher energy levels the further away they are from the nucleus. Now let's focus back on the electrons. Now electrons in the first shell are closest to the nucleus, so they experience the strongest attraction. Therefore, they have the lowest energy level. In contrast, electrons in the outer shells are further from the nucleus. They experience weaker attraction to the nucleus. In fact, the further from the nucleus, the more energetic the electrons because the attraction to the positive nucleus is weaker. Now let's take a look at how electrons are arranged in an atom, which, let's recall, is called electronic configuration. Now here are the rules to follow. In this video, we'll be focusing on the first 20 elements in the periodic table. Electrons are arranged in electron shells around the nucleus. The first shell can hold a maximum of 2 electrons. The second and third shell can hold a maximum of 8 electrons each. Electrons always fill the shells, starting from the one closest to the nucleus, which is of the lowest energy level. Now let's take a look at the first 20 elements of the periodic table. For each element, we will state its electronic configuration, the number of occupied electron shells, and the number of valence electrons. I will go through 5 examples with you first. Then pause the video and try the rest yourself. Once you're done, you may resume the video to check your answers. The information in this table is extracted from the periodic table. The number on top is the atomic number or proton number. The number at the bottom is the mass number or nucleon number. For each of these atoms, which is electrically neutral, the number of protons and electrons must be the same. Hence, we can determine the number of electrons in each atom just by checking the proton number for each element. Now, the first element, hydrogen, proton number is 1. Hence, number of electron is also 1. The electronic configuration is 1. Only the first shell is occupied. Hence, the number of occupied electron shells is 1, and there is only 1 valence electron. Next, helium. Helium has 2 protons. In an electrically neutral atom, the number of protons and electrons must be the same. Hence, helium has 2 electrons. The electronic configuration is 2. These 2 electrons will fit in the first shell. Hence, number of occupied shells is 1. The number of electrons in the outermost shell is 2. Hence, valence electrons is 2. Okay? Now let's move on to lithium. Proton number is 3. Hence, lithium atom has 3 electrons. The first shell can only take 2 electrons. Hence, the remaining last electron will go to the second electron shell. The electronic configuration will be 2, 1. Number of occupied shells is 2. How many valence electrons in the outermost shell? It's 1. Hope it's getting clearer now. Let's move on to boron. You should know by now we just need to check the proton number to determine the number of electrons in the atom because atoms are electrically neutral. Boron has 5 electrons. First shell takes in 2 electrons. The remaining 3 electrons go into the second shell. Hence, the electronic configuration is 2, 3. The number of occupied shells is 2. For part 3, the valence electrons in the outermost shell is 3. Last example, let's focus on potassium. 19 protons, hence 19 electrons. First shell takes in 2, second shell takes in 8, left with 9 electrons. We will need the third shell to take in another 8, and the fourth shell to take in the last electron. The electronic configuration is 2, 8, 8, 1. The number of occupied shells is 4, and there is 1 valence electron. Okay? I hope things are much clearer now. Now pause this video and try to complete this table yourself. I will see you when you're done. Hello, welcome back. This is the completed table. Check your answers. Next, I'll go through with you several questions to test your understanding on electronic configuration. Now, question 1. An atom has a proton number of 11. Now, there are 3 parts to this question. How many electrons does it have? Write its electronic configuration. And how many valence electrons does it have? For part A, in an electrically neutral atom, the number of electrons is equal to the number of protons. Hence, the atom has 11 electrons. For part B, write its electronic configuration. Now, first shell takes in 2, second shell takes in a maximum of 8. Hence, for this atom, the electronic configuration is 2, 8, 1. Now, how many valence electrons does it have? Valence electrons is the electrons in the outermost shell. Hence, there is 1 valence electron. Question 2. An atom has a proton number of 17. We are to write its electronic configuration and determine how many valence electrons it has. Now, first shell takes in maximum of 2. Second shell takes in a maximum of 8. Hence, we'll work it out. Okay, the electronic configuration will be 2, 8, 7. Valence electrons is the electrons in the outermost shell. Hence, for this atom, there are 7 valence electrons. Question 3. Which element has the electronic configuration of 2881? Now, 2881, let's work out the number of electrons it has. 2 plus 8 plus 8 plus 1 is 19 electrons. Alright, so for an atom, okay, which is electrically neutral, meaning it has no charge, the number of protons and number of electrons must be the same. Hence, the number of protons for this element is 19. Now, as mentioned in the earlier video, proton number will give the element its identity. So, let's look back at the periodic table. Okay, which element has proton number 19? Is potassium. So, this element must be potassium. Question 4. An atom has the electronic configuration 284. Part A, what is the proton number? And part B, which group in the periodic table does this element belong to? Now, same as question 3, Let's work out the number of electrons, and from there we'll be able to determine the number of protons. Okay, 2 plus 8 plus 4 is 14. Number of protons and number of electrons in an electrically neutral atom is the same, hence the proton number is 14. Now if I ask you what is the identity of this element, then you can refer to the periodic table. Alright, with the proton number of an atom, you'll be able to determine the identity of the element. Alright, so this element must be silicon. Which group in the periodic table does this element belong to? So elements with 4 valence electrons, it belongs to group 14. If you refer to the older version of the periodic table, okay, which uses the Roman numerals, then it will be group 4. Now in this video, we have learned that the way electrons are arranged in an atom is called its electronic configuration. The outermost shell is also called the valence shell, and the electrons in this shell are called valence electrons or outermost electrons. These are the electrons involved in chemical bonding. Now the rules for writing electronic configuration. 1. Electrons are arranged in shells around the nucleus. 2. The first shell can hold a maximum of 2 electrons. 3. The second and the third shell can hold a maximum of 8 electrons each. And take note, this is only for elements with proton number 1 to 20. Number 4. Electrons fill the shells starting from the one closest to the nucleus, which is of the lowest energy level. Now, if you find this video useful, please subscribe to the channel and like the video. Don't forget to share the video with your friends. If you'd like to have more chemistry resources, you may check out my website. The link is in the description. Have fun learning chemistry, and I will see you soon.